let's just have a look at it. You know the Industrial Revolution, yes?
Yeah.
It often gets watered down quite a bit, like it was terrible, it was really bad. Have you not noticed the narrative on that? And actually, it was a really good thing. It's actually the seeds for the next step for human evolution. If you think about it, perhaps on a planet, on a globe, where it's, sensitive to changes.
Yeah.
Okay, it can't be sustained on the Earth for long term. However, it's training grounds for the next step. So what do we need for an industrial revolution, really? Because look at what it created. It actually created socialism, didn't it? If you think about it, all right, perhaps it wasn't perfect, but that's a different mindset from today, isn't it? We can look at that and think, okay, where was it a little bit shady where people, have that opinion that it wasn't great? So I guess with some of the things that my grandfather has spoke about, that is the Industrial Revolution, isn't it? And some of the things that we read in town, Thetford Town, which is more like a city these days, but still, it's very positive, right? There's a lot of freedom to it. Interesting. So yes, so we also have farming as well, right? Which is backbone of anything, but farming can be detrimental as well as prosperous, yes? So if you think about it like this, we're going to say N and A, and we're also going to have N and N. Oh, that is so squeaky. You wonder why it usually triggers the birds off. Anyway, that's probably better.
Yeah, that I can see.
So N and N is, we want to think of that as prosperous, yes? So you can think of a hospital here in Norfolk and Norwich, but it's not standing for that. It's basically nitrate nature, yes? And then we've got nitrogen algae. So in doing so, we can often feed algae blooms from manure. Different stuff like that, yes? We got to be able to be careful with this, especially when going to space. That thing is not great. But can you turn nitrogen into nitrate? That's the thing. Do you think it's possible?
Chemistry, it must be possible.
Which is more beneficial, isn't it? So therefore you can get the best of both worlds. If you hit it through a certain type of system, you need this for this. Transform it into this, which then goes on to support that. So it's a careful exchange of gases. And did you know that even our cars that are run by fuel rely on this?
Yeah.
Well, if you think about it, nature producing oxygen and also certain types of plankton as well, I think it is. Isn't it plankton? Can't remember. Either or. Ocean growth.
Ocean little creatures, they are plankton.
But also rivers too. And this being mixed up into water is a very good thing too. That is undoubtedly so. This one perhaps produces algae. Algae is very quick to bloom, and when it blooms, it starts having a detrimental impact on it. Doesn't it suck out oxygen more so and creates more carbon eventually? Is it that one, algae? It basically
covers
stops,
it covers the surface of water body, and the fish cannot get oxygen because it doesn't exchange. It blocks basically the exchange of oxygen.
So dealing with algae is dealing with its food source, limiting its food source, not to completely eliminate it, but the best of both worlds, N and N, positive. Life-saving in that aspect. So that's quite a nice thing for Norfolk and Norwich N and N. I kind of like that. So so we're looking at the Industrial Revolution. So it brought about a lot of good things that actually are still rippling through society today is from the Industrial Revolution. It really cleaned things up. Plus, a lot of power structures already understand this intimately and can create systems. Okay, so what did you rely on in the Industrial Revolution, technically? What do you think they were?
You need coal for Industrial Revolution.
You say need,
or the
wrong?
First one.
But still...
the people, I mean, they used it.
No, it's absolutely correct what you say, but you can get, need coal, okay? Switch it. What is it?
I don't know, what do you mean? Fuel.
Which then equals what? Heat.
Yeah.
Which then allows you to do what? What do you need all of this for? See, we stick on need and coal, and you're absolutely correct, but that's a surface dive. When you dive in a little bit deeper, what is it? It's
to
a fuel.
move and to,
Therefore, there's heat.
and to heat houses.
What do you need the movement for? Yes, we can say that it can be to heat houses or different things like that.
Transportation.
But also, pottery, metal forging.
Yeah.
Yes, this is basically the backbone of everything. So would we have knives and forks? Would we have saucepans? Would we have door handles? Would we have the metal structures inside the houses that support most of them? Would we have pins? Would we have railway? Would we have railway tracks?
No, that all needs that or needs
Would
uses that.
Yeah, okay, perhaps it's different with alloy and different things like that, but still, what about the old times is tin? Food was stored in tin.
Yeah.
It's changed a little bit now, but even still. Also glass making. So you see that from this industrial revolution, and even still, we're still heat using the same process and methods because you need a radiator. How do you forge that? You got to heat it up, right? And then you've got all of the pipe work, the copper, electricity, computers, solder. Again, perhaps not done with coal. Pressed clothing. So we've got fuel being a fuel source, but we relied on coal. What if you flip the fuel source and then call it the sun?
Yeah.
Now, how do you do it if you can't get close to the sun? Magnetism. No, magnification. So we could put mag lens, yes?
SE.
SE, yeah?
Yeah.
Thank you very much. So let's have a mag lens. So do they then need to get closer to the sun? Okay, so on Earth, a mag lens will not work. Yeah, if we think about it. And what do you need that for? Then what else do you need? Metal.
Yeah.
So coal, metal. So we could then eliminate that from fuel, sun. Then you need resources, which is what's abundant in the universe. Well, you've got to mine it. You still have to mine it. That's absolutely. But you also need metal, yes?
And you need glass for lens.
Glass is easy. Glass is abundant. Sand is abundant. It'd just be slightly different, and it might need playing around with, but let's have a look at Martian sand, Regenwurf on the moon, beads of glass, sand, glass, all of this stuff is abundant, and it's really great because inside a flask you require glass. If you think about the old steam trains, how massive they are. One I remember particularly is the Flying Scotsman that used to come hurling back, and the steam train over in the railway track that they do periodically. Nice to smell it, isn't it? It's a really nice feeling. Nostalgic in a sense. Well, we think transportation is train, but there was also a lot of also ships were built on this as well. So we understand that there was a level of water. Transportation was done using rivers mainly. Trains, yes. Again, still water, still river, because you have to put water in it in order to generate the steam in order to get the movement. Now we'd understand the river, so current, flowing.
Yeah.
So what about if we then said space? What is orbit? What is orbit, if not a river? Let's say if we do an orbit from one body to another, I didn't do it in the figure of 8. I can do it in a figure of 8 too. It doesn't really matter. It's very symbolic. Either or. What is that now? That's a current.
Yeah.
Space allows you, with virtually no resistance at all, well, minimal, but still, it allows you to then create an industrial revolution that railway tracks evolve into crafts that maneuver resources, again, mining, going down to the planet's surface, particularly. You understand that there's metal on Venus, but Venus is a hothouse.
Yeah.
Well, it's good that Venus is a hothouse. A lens in space, a mag lens in space, will generate heat if you can't get close enough to the sun. Now, if we move closer to the sun, does it increase the magnification, which therefore does it increase the heat, the temperature? We know that if you use a magnifying glass in the winter, it's pretty crap. What about in the summer? Next one. What happens if I move to the equator? Next one. What happens if I move into space where I haven't got these things called clouds and atmospheric particles getting in the way of the experiment? How much more hotter can that actually get?
Yeah, exactly.
Is it possible to get closer to the star? eventually to be closer to the star, if it's not achievable in the meantime, can we not focus a load of lenses? Because if we have one magnifying glass and we've concentrated a very small beam, but then we have another one and we concentrate the beam and we do another and we concentrate the beam onto the same area, are we going to be generating a large amount of heat from that?
Yeah.
The more you have. And then if it takes 3 to create the beam of this size, what happens if you then add more to move the beam of equal intensity? How much more bigger? And considering glass is so abundant, literally because of the sand, this is easy to make. Sounds it's complex, but still it formulates from the Industrial Revolution. Are you going to need food resources out there? Yes. Steam trains are converted into what? Big modules. And again, if it's going to be finding metals, glass, and whatever else, what type of houses can that build? What type of farms can that create? Ones with a balancing of the gases. What type of science does that create? What type of education does that create for kids going forwards? If there's more, well, actually, this started to work, and then they get thinking. They get a little thinking caps on, and off they go, and they become the new pioneers. Technically, it's what it is. Off the backbone of an industrial revolution. And again, this industrial revolution that is well known, it's well documented, they've held on to it okay on the earth, it's kind of reduced down. Yes, logically, if we were to continue with that one, we're going to run out of resources because they are rare earth resources. But again, even if you were to take this understanding with a lens, it doesn't have to be. But let's say you go around Venus. And rather than that energy hitting onto Venus's surface, which creates it to be a hothouse, there's a lot of good treasure on that particular body, of course, and also Mars, there is too. But closer to Venus, if you were to take this energy and utilize it into something else, you're going to, by a default, you're going to cool down Venus. Then that means that it's more accessible. What happens if you concentrate this beam onto solar panels or anything else? If you cooled it down, the gas is going to start collapsing down on the particular body, and if it is, then there's lacking of atmosphere. Making Venus into a moon wouldn't be a bad thing if you can do it. That's next thing. You want to be utilizing that energy. But what's more, if you don't need to have the heat, if these rotate into shade, you're basically turning off the device, but you're still blocking the light that gets to Venus. And eventually the atmosphere should collapse down. It could make things a little bit more easier to mine stuff, and therefore you haven't got so much of that gravitational influence plus atmosphere. I mean, you're going to break away from it, but I think a lot more easier. I think that if you have more atmosphere, it's a little bit more, plus mass and size, yeah, don't get me wrong. But what happens if we expand Earth's atmosphere? What happens to those satellites? They were outside, but the atmosphere expands. What's going to happen to those satellites? They're no longer in an orbit. So they're going to fall back to the Earth, aren't they? So look here, there maybe, because you look a little confused.
No, I wonder if it's so thin atmosphere that it would have that effect.
If not, we would all be flying satellites in the atmosphere. So why do we not fly them in the atmosphere if it's so weak?
Yeah, no, I was just wondering that.
So therefore, if we were to expand Earth's atmosphere,
then can you lift them before you do that?
Well, if Jupiter has a metallic core, then therefore its metallic core has got to be quite small.
Yeah.
But its atmosphere is very big. But it creates a gravitational pull.
Yeah, I see.
If you were to shrink it, would that pull, would still be space on the outside? Therefore, there's still the space's influence and not the planet's influence. Yes, I agree with mass to a certain degree, but I also believe in atmosphere. It's a bit strange that atmosphere reminds us of water. What happens if you put a piece of, I don't know, lint from a tumble dryer close to a piece of water? It absorbs. It seems to have this pull to it, and atmosphere seems to be a lesser condensity of water.
Yeah, it's
and
like
so water
very
is
thin
atmosphere,
water.
but concentrated atmosphere, and then we have a less concentrate. And therefore it acts like a bubble, doesn't it? The planet is like a bubble.
Yeah.
If anything sort of comes too close, it's going to pull that in, and then the rest is history technically, because the Earth's then gonna, it's really gonna pull that through. So if you shrink the atmosphere, there must be a counter, and then that is true. M equals whatever it is, mc square. Yeah, about mass and breaking away from it. But I think that it needs a next layer of also atmospheric mass. What is that pull ratio of that atmosphere? And again, does atmosphere mimic bigger mass? That's the question. So without an atmosphere, or a less of an atmosphere, is there less mass? And then that is identifying the planet without an atmosphere. It equals this much mass plus pull plus this. But with an atmosphere, that equation, sure as hell, must increase, because the same way satellites, right? If they're orbiting around. So what happens if we all of a sudden, because it's hard to do so, isn't it? In the meantime, if we were to expand the atmosphere of Earth, all of a sudden, assuming that life could survive that, let's just say, and it expanded out to where the International Space Station is and engulfs it, what would happen to the International Space Station? Is it still going to orbit? Because if it were still going to orbit, then it means an airplane that takes off just needs to fall into the planet each time and go around, and it will make an orbit even in Earth's atmosphere. But it doesn't. Why? Something now has a hold of you. I wonder if it's the atmosphere plus the particles that you then interact with as well. Think about it. Although they seem very thin, those particles now are going to start hitting you, or you're going to start hitting them. Either or, that is going to start slowing you down. What happens when you start to slow down? You need a constant fuel source to keep going with propulsion. So now in space you're falling, and as opposed to falling, because there's not much resistance, and if there is sort of space debris, perhaps pieces of sand that are not moving too fast to damage International Space Station, but there are particles around the Earth, and depending on how close to the Earth you are, I'm pretty sure the International Space Station has to thrust up every now and again because of this bombardment. It slows it down slightly. Not enough to notice it, but over a long period of time, that is enough to begin to slow it down. And then the objects begin to drop into Earth's atmosphere. And then it becomes gobbled up by the planet. So that's how I look at that. And then thinking it backwards and then looking at Venus, puffy, incredibly puffy. Perhaps it's easier to deal with if you can make that atmosphere collapse it down on itself and shove it in a container and keep it at that. You've just suspended the atmosphere. You haven't lost it. You've saved it. Wise ones would collect it. Others might just want to strip off the atmosphere, because we often focus on terraforming. But what's the opposite to terraforming? Where you try to puff up an atmosphere and you try to then balance the gas, that's terraforming. But what happens if you want to de-terrorize it? I mean, that's something. Yeah, the reverse of terraforming, which is to collapse it back. We often do focus out on how can we make this more like home? Man, fuck that. How can we make it so we can grab all of those things to bring it home? Make it easier for ourselves. So at the moment, we'd look at Venus, hothouse. Now, is that heat worthy of anything? What do you got on your surface? I mean, there are trace metals on Earth found on Venus that seem to be abundant, and they frost the mountains, the mountain peaks, tellurium. Believe?
Tellurium?
Yeah, maybe either or.
Something.
Tellurium, glorium. I'd like to have a little twist with it. Either or.
So is it because it's hot that the metals get to the surface as well?
Yeah, it's interesting. So certain stars can actually rain. It's possible that they can rain iron based on how hot they are. Liquid is liquid. Liquid is interesting. And also, when we think about iron, when it's cooled down, it's technically a supercooled liquid. What's its natural state? That is the question. Well, gas. Okay. So what is it now? It's been compressed and it's frozen. It needs X amount of heat in order to forge it. Yeah. So again, it's frozen. That is technically is ice. So that's just the way I look at it. And the ice can also become liquid, molten. So therefore, liquid stage. And then there's evaporation stage, and then there's recondensing stage. I mean, it seems to always remember, but it based on the ingredients that go into it and what those ingredients hold at. So if you're constantly subjecting iron to heat pressure well, and you keep it at that happy medium Goldilocks zone, it's probably going to stay like iron. But if you exceed the pressure, it's going to jump from iron to the next one on the periodic table. That's giving it more or giving it less. It's the same way as making fire. As someone once said, it was Tim that said this, that you can do all the friction that you want, but if you are slightly below the catching ratio of that catching fire, it will never catch fire. It will smoke, it will appear to, or smolder, but you just need just that little bit more oomph in order to change the ingredients. And then the ingredients change, then you get a reaction, then it's fire, then it goes on from there. That's an interesting thing, isn't it? To think about that. And if you do nothing with it, then the objects don't combust. You see, and then there's a breaking down from that. What happens if you freeze it? It becomes more fragile, different things like that. So, yeah, everything is set to a frequency like a Mayan calendar, although a tuning mechanism. When it's set like this, like this, like this, like this, the ingredients, the factors that go in, it needed a star to create this to start with. Okay, those have that set in that frequency to allow it to just alter a little bit more. Now it's into this, now it's into that element, now it's into this element. And then when it explodes from the star, well, the mechanisms have changed to those ingredients. And then it rendezvous with a planet. Well, while it's on the planet, it's going to start to rust. Okay, there's another factor, water, this. What's the outcome of that iron now? Well, it's going to change. Why? Because now the ingredients that are going into it are now altering its frequency, technically. So yes, and then there's maintaining it. So if we buff up metal, protect it, especially iron, and we make it so that it's impenetrable to the elements outside, how long does it last? One piece that's natural, unprotected, uninterfered with by humans, and another piece that's been interfered with humans, but they're constantly maintaining those ingredients inside it. Now, whether that's painting it or whether that's giving it a lacquer, which one has different ingredients to each other? This one's now got different ingredients on the outside, sure. It's been forged on the inside, and humans have made a Mayan calendar, technically, not a calendar, and have changed the frequency to keep it at that stasis. Suspended animation, while this one is technically not suspended. It's basically at the whim of the elements or ingredients that are going into it, and then it starts to break down and it becomes very different. This one holds its shape, so you force it to hold memory, so you freeze it in time. That becomes a time machine. As long, technically, it doesn't, it's hard to explain it, but still, it's preserved it. So you've suspended it in animation. I like it like this, now I want to keep it like that. Pause. This one, I don't care about this one, whatever. And it goes on, and then you could say the creator or whatever it is, the universal processes are now taking charge of that. Do you want it? Sure, I do want this. Okay then. I want to keep it like this though. The elements? Yeah, all right then. These ones? Yeah, we're cool. All right, we're going to get on with these. Becomes a question in a way.
Yeah.
And that's what the Industrial Revolution is. It's basically freezing things in time capsules. So sand, forged, glass, there you are. As long as it stays in this particular environment, it's very protected. Outside, not so protected. In a river somewhere, well, it's going to turn that back into sand anyway. And it's a very interesting process, isn't it? Don't you think?
Yeah.
But while it's in the house, and if the outer walls are protecting it, the individuals inside it are protecting it, blah, 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 how long can that last? Indefinitely.
Yeah.
Imagine that as a family heirloom. Someone since hunter-gatherers made a piece of glass and have passed it through families like a sacred jewel. Becomes precious. Why? Because it's old. Then how many hands have held it? How many people have looked after it is the question and kept it in that suspended state. That's a fascinating thing, that is. To pass that down, that's a true heirloom. And it's got nothing else other than a sentimental value. But future generations can then look at that piece of glass and wonder all the hands that held it and have kept it in that suspended animation all the way through. Then this puts real value in the most insignificant, which we would say sand. And then when you look at its backstory of how long you've kept that in, and then the planet, and then the star, and then this that created it, that went into all of that, and then from the whole universal structure. It's beautiful, isn't it? It's wonderful.
Yeah, it is, isn't it?
Could you imagine suspending the whole universe? I dare say it could be done. How big are your numbers? How big do you want them? The universe asks back. Have you seen the size of me? There's enough room for more and more, and more the merrier. Suspending different things and getting it right. So anyway, the Industrial Revolution again required fuel. Technically, as the main art is fuel. That happened to be coal.
Yeah.
Interesting. Got nice and hot. Now compare that to the star. I mean, that's looking like a cold day. That's looking like an ice age compared to a star. That is very cold. Then what can you do more so with that? And again, if it's the hotter the fire, the purer the metal, more pressure. Well, interesting. If that's what you can achieve with coal, this is what you can achieve with this. This is what you can. What could you achieve with the sun? The Industrial Revolution will once again kick off. Now, what can that do? That creates abundance. Rather than us looking at it as, look at how, I think that we should look at how it destroys an environment. Yes, don't get me wrong. But we can also look at it as how much it's been very beneficial to the environment. And if we look at it in a negative light of how much it may have damaged the environment, going forwards, it allows you to rectify and enhance the process. Unfortunately, something is going to have to be transformed. So like a planet, pick Venus. That will have to be transformed into something else. It's recycling, isn't it? The universe is going to chop that up anyway, or perhaps make it into a star, or perhaps it's going to be devoured and put back into gas if it reaches a black hole. So yes, it changes are good. Perhaps not on your vessel when you're temperamental with the environment, right? The environment is very temperamental. It sort of swings between 1 and 2.
Yeah.
But once you've created something that is a tempered time capsule, which is the optimal operating ratio for humans. And then we can go further with this. What happens if you take a load of electric eels and put them on an entirely specific environment that amplifies what they are, grows them to the buffer zone, and then influence this onto a planet? Something the size of the Earth. How much energy is that?
Yeah.
How much could you tap in off of that? That's a lot, right?
Yeah.
You know, as they're in small numbers in a river, a few of these in a tank won't do much. Yeah, I wasn't thinking of a tank. I was thinking more like the size of a planet, maybe the moon, and then making a habitat that was really great for them. Just wondering. And then it asks you if that's possible. And if it is possible for them, then it makes you look at yourself a little bit more as your own species. What can we do there? But actually, it's nature, really. Nature is the sentinel, isn't it, of everything.
Yeah.
If it produces a good amount of oxygen, that fuels your cars.
Yeah.
What makes a car move? Petrol, miss. No, oxygen, petrol, all sorts of things. Environment, atmosphere.
All of it together.
There's a lot of things. I mean, if we just look at it vaguely, yes, fuel is a contributor, but it also requires wheels.
Yeah.
It also requires a combustion engine, pistons, piston rings, oil. There's a lot going into it. Water, cooling, exhaust. So there's a lot. And then there's also oxygen is one of the main ingredients too. Just you don't need to fill this one up with it. That's the difference. So yeah, that's fascinating, isn't it? But it leaves you with the understanding of transportation. And what it did was teach you how to get faster and faster and faster. And then you reach a buffer zone on the Earth. How fast can you realistically go on the planet? Well, this fast, that fast, this fast. How much more faster could you go in space without that?
Yeah.
Friction, that constant friction. That's what causes the heat. That's interesting. And space is pretty damn cool. So you take the old trains that were being built, the massive steam trains, the fucking huge ones, right?
Yeah.
They make people look like this big. Wait,
Yeah.
what? It's insane, isn't it? Could you imagine that being converted into a house with a module of metal surrounding with a flask material? That's big, right? That's big. You can see if these people are just the size of the frickin' wheels, like ants. Can you imagine? Because when I look at that, I think, shit, if you converted that into a house, it'd be bigger than an RV. It'd be bigger than a mobile home. Jesus Christ, that is huge. align that correctly. And what happens if you could make glass? All right, it's very fragile, don't get me wrong.
Yeah.
But if you've got nature growing in it, does it need to be all that great? Can it hold the heat? Yes, you can deal with pressure. Yeah, that's easy. Go on, you need to do what you need to do.
Excuse me.
All right.
Yep.
I'll do the talking, you do the coughing for me. That's good.
Yeah, I'm sorry, I
No,
apologize.
you're all right, I don't need it. And, yeah, so you can
Would
see
you
that
make like a few smaller modules just in case there is a problem and make
Lifeboat.
them in a one home, like, so if there is a problem with, you know, losing air from one, you can just close and go into the others? Or
Yeah,
would
so
you make
basically
one?
mean like sections, yeah?
Yeah, section thing.
Or it would be having access to a suit that you get into very quickly. The training would be the fire drill, technically, because that's what has been taught. Know what to do during a fire, know what to do during this. Technically, know what to do when you're leaking gases.
Yeah, yeah.
Or have some sort of robotics that the suit comes and clops onto you, just in case you're reaching decompression sickness by then, and you've passed out, whatever it may be. The suit finds you as opposed to you find the suit. Either you can find the suit or the suit finds you. Bubble. And then it starts inflating with, it's basically a pod. All right, great. And then that relies on humanity. That relies on other people around you to know that there's an issue, the alarm triggers, and they have to be self-retained firefighters in that aspect to come and get you out of that dangerous situation as best as they can. And if that means that they have to suit up and then go into the part that's got the breach, you're inside a bubble, then they can maneuver it. There's enough room to pull you into their module, close it off, and then pop your bubble, which technically you wouldn't pop it because that would do, but you know, get you out and then get you the attention that you need. And I think that that can save you quite a bit more often than not. Yeah, there's also making certain substances that stick around the outside that when something penetrates it, or if there's something breach, it glues over very quickly.
Yeah, some kind of foamy,
Yeah.
gluey, jelly stuff that will close that area, that little breach or something.
So that would require basically a liquid crystal in the center of it. But once it's breached, it automatically seals. It's a self-sealing. It compromises the hull, but you don't leak gases. You then are able to control you take those gases out as opposed to them just venting off, because once they're gone, that's gone. But it self-seals enough for you to then take those gases out. Once they're gone,
for you to
then you can
leave
fix
safely.
it. Then you can repair it.
Yeah.
And then the hull's integrity is back to 100% again. And again, this becomes routine now, and you can either get bots to do it, that basically bots that are inside the solution, that patch from the inside.
Yeah.
This is easily done. I say easily, not really. If it is reacting with oxygen, the substance stays squidgy in its own little right, but as soon as something breaches, the oxygen from the module fills into this chamber anyway. It's got to try and bubble through it, and then this creates it to set like a resin, fast-acting resin. That's a self-sealing, and then that gives you time to patch the panel on the outside. Yeah, that works. Yeah, that can work, and how you remove that from the inside or not? Because again, if that stays set in there, that will also need removing. So that the liquid can then go back again. You don't want hard pieces in there because if there's lightning never strikes in the same place twice. Wouldn't trust that process.
No, it does.
With meteorites.
Yeah,
You're probably going to get a bombardment and maybe they'll hit in the same place or roughly the same area. It's unlikely, but if it does, then you probably want those hardened pieces out the way once you've fixed what you need to fix. Interesting. And if that means punching a hole all the way through to remove that whole piece, where there's no oxygen there to react and then seal it over from both sides, and then the chamber fills again. Trying to remove, there shouldn't be any air bubbles in it anyway if you do it that way. Interesting.
Yeah.
Wouldn't you think so? Yeah, like a puncture repair kit, self-puncture repair kit. That's a great way to do it. Interesting. But yeah, no, the Industrial Revolution, it really paved the way. It taught you things you don't even realize that it taught you. I think all of us, this is the next step, because it is then the Industrial Revolution on steroids is the next step. And then what? Using the star and different things, which then gets you ready for what? There will be the cooling off period again. What happens once you've very future, once you've mined what you can from your star system, and then it's time to leave. Do you see the Industrial Revolution will pick up and then it will begin to subside, but it gives you the next step of being able to maneuver to another star system. That's the dipping down ratio, which we've seen now. Go from the Industrial Revolution to the dipping down. And what it's taught you is power struggle. It's taught you opposition. It's taught you how humans rely on different things and how they are, how do you call it? They begin to respond to the decline. We understand that technology has bridged the gap for boredom. And does it work where you're able to get this? It also teaches you about control and where the barriers should be in the limits and the buffers. All of this has been nothing but data. It can be looked at as one great big problem, or it can be change your mindset. It's data. You've done it once, blindly. Second time, you do it with more knowing. More knowing means that you are more in control as opposed to out of control. So it gives you an illusion of out of control, all the stress factors that come. And it teaches you data on emotion, how you feel in that moment, how people feel in that moment. It's all reciprocal, all for a particular purpose. It all seems invisible in the beginning, and then it opens itself up to all of the buffer zones. It seems accidental until the knowing is dropped in. That's the knowing part. And then when you look back on it, we know this. We went through this again. Then you make better decisions. Perhaps not you directly, but generations that are going forward. That's if we're not reliving. And even again, that reliving, it only takes one strand, really, technically, from... You're all branches of the same strand. And even if one bloodline collapses, it doesn't mean that these ones don't continue on, because the strand is already there to rebranch again. It's never truly lost. It's only temporal. And then these fractures then go again, because there's so much in the mixing pot. So there's more variations, there's more this, and this. And if your bloodline goes this way, it can also go that way, but still come back to this way, as well as still paralleling off on this way, and then merging out and going this way, merging out and going this way. If this one collapses, it will just temporarily be a blip, but it's still there. It just moves into another one and it branches back onto track again. It's interesting, isn't it? All of this sort of stuff. Well, that's if you believe in reincarnation and stuff like that. Interesting. Not saying it's impossible. Hey, leave it a mystery, because it makes it more fascinating in that way, doesn't it? Is it? Isn't it? Could it be? Could it not be? Interesting. And some of these pauses in that bloodline, can it make it more stronger next time? And therefore it goes invisible, because if any have eliminated a certain bloodline, it comes back. It's never really truly gone. Perhaps not in that same framework that you recognize, and therefore it creates you in the invisible. This one didn't work, but these variables do, and they escape the attention, so to speak. Interesting. There's nothing quite like anything being higher than that. Beautiful, reassuring, and everything else. So, when we say coal, we often associate this now with panic. Everybody does, when we should be calling it fuel. Fuel sounds better. Coal sounds panicky now. It's your trigger word. That's trigger. You see? Industrial Revolution. That's also perhaps maybe a trigger word for the people that are moving forwards now. And then it's like, who is putting all of this sort of green mishmash into the mechanisms that exist? Now, is that because we're supposed to stay here on the planet, or, you see, that's the way I look at it, that it could be some way of trying to affect narratives, the minds of people. Oh my God, the planet is nearly dead. We can't do this, this, and this. And it's to then design a load of fear in you. So that when you think about Industrial Revolution, it triggers something. By design, triggering that response then means, oh shit, we better not do anything. We're going to end up farting in tubes soon and bagging it up. better not leave any methane. I'm sorry, but that is true, though. That's what we'll end up doing. Shoving them up cows' asses and everything, you know? Collect this methane. So it creates this trigger. And what does that trigger do? Is that liberating or is that suppression? Is that being used in the correct way? Let's not worry about that. Let's look at it and think, is it a trigger if I let it be a trigger, or is it a lesson? Yes, very true that it does do this, this, and this. Going forwards, how can we make this better? Well, we'll be relying on this. Okay, that eliminates a lot of things. One, it generates a shit ton of heat, doesn't it always?
Yeah.
Where's summer? Well, it's all year round if you can orbit that thing very closely.
Yeah.
That's incredible. If you're pulling things out of the ground and plundering precious metals from other planets, that does two things as a bonus. One, new resources, unknown resources waiting to be discovered. That's breakthrough, that's science, that's education, and that creates the next generation of pioneers. The ones that find it, claim it, whatever else it is, but say claiming is a wrong word. But making that discovery, that puts a lot of passion back in and purpose back into people. Then is what you can do with those. So therefore, there's more than enough people. Some people want to do this, some people want to find it, some people want to play with it, some people want to create with it. That's perfect. Go with that. Also, you've got a fuel source. That's one thing. You can cook with it. And you're not really transferring any gases, really. Technically, that's going to be doing it naturally anyway. Well, it's either going to burn up and continue burning with or without your taking from that. You know, with or without you, that is going to continue. Then this makes the narrative next time become more impossible to deal with. Oh no! Jesus, man, we're removing all of the heat from the start. I mean, I'd love to see you stop that. It's like trying to punch. Never mind. It's not, oh my God, it's like a gnat trying to stop waves, isn't it?
Yeah.
By then, it will already be educated of that. If we go, yes, going green is beautiful. Don't get me wrong, it really is. Why? Because it paves the next way, for sure. And it helps us to be aware of the exchange of gases, which then, that teaches us going forward that if we make a module, well, we fucked up a little bit here. Perhaps that wasn't the best thing in the world. But applying that out there and then also bringing it here, two vampires, one steak, as they say.
Yeah.
Don't you think so?
Yeah.
Because that is now teaching you going forwards how not to make the mistakes. And what else? That next method is medicine to the planet. There's nothing quite green quite like that, is there? And then that turns off that fear. And then that makes people think, what do we learn from that? It's about how we go into it. Fear and everything else. Often than not, doesn't it keep us in that center ground? It's one of the hardest things to walk past is fear, right? I'll give you a headset, walk through the forest. You're not going to know when I say anything into that video, and I'm going to make some very scary sounds in that I know will trigger a response in you. First thing you are going to do is probably want to pull that headset off. Don't do it. Next thing, you're going to want to stop. You have to fight that. Because you want to freeze. You want to stay in the... Oh, shit. Oh, doesn't it keep you... When we look at this, that spoon-dripped fear over a longer period of time keeps you in that position. It anchors you to the floor. It anchors you into this, if we do this, what's going to happen? Oh, I might break... this might happen. The environment. Seriously, if they really cared about that, debt wouldn't really be a thing. We'd be looking at the debt we are leaving in us living in this way. What's worse for the environment? Burning stuff or staying on a planet that's dwindling resources? Which one is more detrimental? Think about that. If you think about it logically, which one causes more? Playing these games that we're playing now, where we go and do all of this stuff, that is creating a carbon footprint. That is creating a exchange footprint. That is creating a gas knock-on effect. That is creating nature destruction. That's what it's creating. In that inaction is more detrimental, and it will take a whole lot of more than just going green to fix that. Because now you've got to make the choice. Am I going to plant? Am I going to grow? Do I pick the stuff I need to grow? Do I live in a tree? Do you build buildings out of trees then? And then it'll be like, well, no, we can't do it with trees because what are the trees going to be giving us? Well, they're seasonal. Oh, shit. What about food? Food, housing, farming, energy.
Mm-hmm.
And then you got to exchange your gases that you're breathing. And the numbers pop out again. And then we'll reach another deficit, which then slowly but surely blinds you to extinction. That's where you walk straight the path. Whereas this way, you know it so well. You know that it was really hard to pull things from the ground. That was difficult. It wasn't easy.
Yeah.
The green way helps you understand that. You can do it. Incorporate the greenness with the technology, with the know-how. Can I factor in some mag lenses into that? What happens if we aim these at solar panels that are working down there? Control what sunlight is there. So if Venus, once again, is covered in absolute heat, light, and everything else, and you manage to block it out, technically block it out, but use it to forge metals, and then you leave some light spots on the planet, concentrated light spots that aim down at solar panels. The atmosphere is less, therefore they're going to use less energy. You see, this is the bit that we don't understand, that walking through this environment is incredibly burdensome. Okay, so is space. Somewhere there is a Goldilocks zone, a happy medium. Earth, you just rose up on Earth, or perhaps you were placed here, whatever it is you believe in. That was not your choice. That is not your best optimal operating system. What happens if your gravity is supposed to be less, that allows you to move? In the beginning, all right, that's going to be a little bit more difficult, but you're going to eat less in that environment because you haven't got the constant pull, the constant push. Do you know how exhausting it is to walk in wind?
Okay.
That constant barrier, I've noticed that, only because I was wondering, do I eat more when I do this? Or do I eat less when I'm like this? Well, we notice this with fish and animals that go in hibernation. They actually eat a lot less when they do a lot less. When they do a lot more, they need a lot more. And therefore, they create more waste. And more waste then begins to build up. That's also very toxic because, again, it factors into this cycle, which is then detrimental for this. Because I think algae is another life form at the end of the day. It wants to engulf. It wants to be the dominant species. That's why all of these hunt and do different things. Some of it is obvious. Lions do it. Why? Because they want to be the dominant species in that particular area. Not too dominant that they eat all of their food resources. No. But they want to give them a half a chance and they want to expand and then become the species. That's the way it is. Algae, well, it has that same push to become. Now the difference is humans have an awareness. They have a capability. Sure, algae, don't want to kill it all out. No. You go in this area over here where you can thrive in that matrix. Humans need this matrix to flourish. But you can flourish too, but not in this one. And nature, you need this to flourish, which again, you can imagine that starting up a type of car, and taking some resources that you've got from here. I mean, even if it is rocket fuel, and you find hydrocarbon, wouldn't it be nice to be able to convert the carbon into oxygen and have a self-fulfilling engine that its exhaust is enough to pump into imaginary a nature habitat that then is enough in that exact moment to produce the oxygen. And the more carbon you put in, the more oxygen it promotes back out, which then allows the engine to run indefinitely just by taking one object, shoving it into the exhaust, and then putting it back into the air intake. Could you imagine that? Or any type of bacteria that grows at that same... That's where genetics work. And if not on the planet, never on the planet, because that can be very detrimental. But in that environment, and once you've figured it with modules, what I need out, what you need in, first it will start very slowly and painstaking. But eventually, I'm pretty sure, bet my money on it, that humans will figure that out to the point where it becomes that quick. Touch of a button, and it starts upping more, let's say, oxygen in. And then in the same regard, it also creates more carbon for the next chamber, Function in this way that it keeps in this self-fulfilling prophecy. And that's great. And then there's another place where you're just going to shit the arse out of it. exhaust it completely. And if that takes a few days, yeah, that's if you're going to be relying on fuel sources that way. But while you've got the star, the sun, this gives you enough time to play that. You make lots of mistakes. Why? Well, because you're going to keep going back to the drawing board. You're going to make something that runs on this sort of engine and a fuel source that you can find from yin and yang. Well, in the meantime, you've got the star. You're using that to forge everything. But in this module, you want it to be able to, once you've eurekaed that, there's enough gases exchanging to keep on going. And therefore, if you are forging things in an industrial way inside there, you want all of those ingredients to recycle so that you can reuse them. Minimal waste as possible, because then when you take that and go to the next star system, you already have this. Sure, it's a buffer, but you've done most of the work from the star. And then as you're traveling through and developing, it gets bigger and bigger and bigger. And before you know it, it's bigger than anything. You could never overpopulate it. It's that big. A bit like the trains. They're so fucking massive, right? Never mind horsepower. How many humans would it take to stop that? Everyone hold on your rope. You want these things to be bigger than you. And then that gives you an opportunity that you can, A, expand comfortably times 3 times your amount. Now you're moving times 4. You're still only at, like, let's say, I don't know, 7 billion, whatever, 9 billion for argument's sake. You're at 9 billion in numbers, but you know that you can do 9 billion times 4, times then 5, then 6, then 7, then 8, then 9. Then you're already ahead of extinction. And what's more, that it would take you way too long to expand into that anyway. So it gives you more to recycle those gases into doing other things. Yeah, it's a very fascinating thing. So yeah, rivers. So we rely on rivers, currents, different things like that. Well, space is that current. Plundering, where you know how to do the earth, that's thrown up a lot of stuff to you. The earth you live on, that's like shitting on your own doorstep. Venus, who gives a shit? Honestly, seriously, who gives a shit? The universe? No, I think that's kind of like, if you want it. If it didn't want you to do it, you would not be able to suspend any of this stuff. And it allows you to do that. So something doesn't say it, perhaps it doesn't talk in the same way, a bit like nature. Perhaps it doesn't see in the same way, but it understands perfectly well. If you want to suspend something, you can. Or it's a piece of glass, piece of metal. Then it's about how long you look after it, which then teaches you how long you look after your species, how long you look after everything else that's walked with you in this time. It doesn't need to be abundance and dominant. But if there's enough room to make them, if you've made the version of like 6 Earths, this is moving forwards. I mean, that's incredible to look into the future like that. That's your potential. Maybe you've not been there yet. Maybe you already have. Who knows? If you can make 6 Earths, and then you can make, 3 of them to support different animals and different stuff like that, what's wrong with that? You would tug them along for. You never would be a zoo. It'd be more like that's the wild place. You want to go there, go for it. And then you've got another one that's all tame. That's the way it was. This is the way we balanced it. Because, I mean, that's real progress. Look down onto that biome and see the way that it's all rough and tumble and then there's this one that's very balanced, serene. Which one has the better benefits? Well, I guess you can get the answer from that, because how well it expands. Never mind how well it expands, how well can you support that expansion going forwards? It's interesting, isn't it? Yeah. And then this stuff can sort of exist, but perhaps over there. And then these other 6 planets that you've made are the ones that sustain you beautifully. Yeah. These are the ones that removed all of that. It wasn't given to you on default. That was automatic. All of this here is automatic. It's not really within your control terribly much. It is and it isn't. That's automatic life, automatic living. Get what you're given. This version, how do I make that optimal for all of us? Rather than it being automatic, you then get into the manual operating system. Yeah. Where you can override it, punch in a few codes, well, technically. And then you work in this manual process. Do I want these poisonous things? No. We can put those over there. So then you'll have a biome of poison, a biome of what is natural, and then a biome of what is yours. Yeah. What works for you? Doesn't matter if you walk in this one, everything is edible.
Mm-hmm.
This one, I wouldn't risk it. These ones are a maybe. We'll see how they turn out, because maybe those poisonous substances may turn into edibles later on. Who knows? It's very unlikely, but still, it's possible. And then you've got this one here that's the wild, the really wild, like yin and yang. Some of these can have poisons, can be medicines. Mm-hmm. That is an interesting thing, but still. And there could be some ingredients that these ones make that these ones don't, but can be very significant later on, very naturally.
Mm-hmm.
Yeah, Earth is automatic. Actually, it's half and half. It's an automatic manual. It's in the transition phase. Right back in time, it's all automatic. Everything was happening for you, whether you're aware of it or not. Then it starts to move over to manual in the automatic structure itself. And then your next step is moving over to fully manual. So in the beginning, automatic was bigger.
Yeah.
Yeah? Easier to draw it. Nope, because you don't want to work. Okie dokie. So this is the automatic.
Mm-hmm.
That's how it was in the beginning, yes? Yeah. And slowly but surely, as times change, you then have automatic, and then you have a sliver of manual living.
Yeah.
Then eventually, you want to flip the equation to be in manual and a small amount of automatic.
Mm-hmm. Yeah.
Because you'll probably take some of these automatic structures with you. Why wouldn't you? I fucking would. Definitely. Why? Might need them later. The future is apparently unpredictable in our predictability, but still, let's just take these. These are a maybe.
Yeah.
We're going to grow them bigger than a... But we're always going to be the dominant ones on that, to be that manual operating.
Mm-hmm.
By then, when you this is when it becomes sacred once again. You have another transition, is when the star is exhausted and you've collected everything from it and you have moved on to another star system. Now you're in the interesting phase. You should have died and gone extinct at this level here. Predicted, doing nothing. You should have gone extinct there. But now you're moving away. This was when your star ended. Which is everything extinction. Star, everything extinct.
Yeah.
See? Then you go beyond that. Ooh dear. Now you're in uncharted territory, aren't you?
Yeah.
Living automatic, that's when everything should have ended. And then you become the guiding light, the light. It becomes very powerful, doesn't it? Something's watching you. Something is paying attention to you.
Yeah.
Yes?
Yeah.
And it's asking the question, can you do this?
Yeah.
Ma? Am?
Yeah.
The AM?
Yeah.
You know? The new dawn, AM? Nice, very good. Interesting, isn't it? What do you think about that? What do you reckon the future generations that would achieve that? Imagine if you were to come back here in that time. Well, how many changes would you see? What would you know that you wouldn't already know? Now your bodies are time machines, or your species is a time machine, or a capsule. It's just going to evolve, of course.
Yeah.
But you've now gone beyond what was naturally given.
Yeah.
That's when it becomes... Oh, you can almost see it. Do you see it? The generations at that moment looking back? And we think that we're living in better ages now. We're still in the dark ages.
Yeah, yeah.
But we don't realize it. That's not something to be negative about, by the way. It's something to be very positive about. That is positivity at its finest. And then that becomes... You become aware of it now. Aware of that. But another awareness is you've already done this. You just got to switch it. Coal panic, trigger. No, 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 no. Fuel.
Mm-hmm.
That feels more cleaner.
Yeah.
Star. That is a resource. Heat, everything else. How much can you cook from that? Especially if you're producing a lot of food. Being able to suspend the food, that is something. To suspend it, and it's edible in any time you decide to eat it. That's interesting. Very interesting. Okay, freezers get you part way there. Not all the way. That will then upgrade that. That is going to be the cheapest way to store food. At the moment, how much is it costing for humanity to store food? Freezers, fridges?
Yeah.
That's a long time, right? Yeah, it seems like such a long time, yes?
Yeah.
But that's a lot of energy that is going into preserving. And then there's the chemical base. But being able to suspend it, a bit like the frogs that get suspended or the wasps in Frozen, yeah, that's kind of one thing. But to be able to suspended animation, gee me, that's something, isn't it? Yeah. And it's still as fresh as the day you suspended it, and it holds that nutrients. That's an interesting. Food never becomes a problem again. And the more you make, the more you backlog, and you can then have loads of it. A planet's worth of food. That is interesting. A whole planet's worth. Can you ever imagine that? That is impressive, right? To be able to suspend it and then it's backing up to the point where, wow, my great-grandfather made this meal. Can you imagine that? 14 generations go by. Oh my God, it tastes as fresh as when they... that's interesting. Yeah, what once was precious and hard to get hold of, now is abundance. Oh, where would that energy go next? What could it go into? There are more stages beyond this, by the way. It seems like it's so easy to achieve, and then it's like, what's next? What's next? What's next? Go too far forwards, and I think that it makes the last step seem... It makes it seem more... I don't know. There's two ways I look at it: impossible or possible. It either, depending on who you are, it either excites you and charges you up, and you're like, yeah, this is it, this is it. But then for others, it might be a bit of a daunting challenge because they don't have your foresight, maybe, or your capability to see it, and it might create fear in that way. So, but it does sort the strong ones from the ones who are just as equally as beneficial to the process. But they're going to rely on you to sustain that path for their path, which is good, which then your confidence causes their reassurance. That's what it does. That's what it should be doing, is resting. And that reassurance, I think, is the pinnacle of all power, is to make people reassured. That. Don't you think?
Yeah.
Reassurance. We know the way. We're heading the way. Don't worry, we got you. I think that's what people want without actually saying it, is that reassurance. That we know we're heading towards something. Not this, but we're heading towards this. And I guess a few alignments towards certain different things. People then start to see it, and then they start to trust in it, and then they start to relax in it, and then they start to believe in it. And then they start to believe in you. And as a byproduct of that, it wants to rub off that they can then begin to believe in themselves. And that is the strongest mental framework that any human civilization, or any civilization for that matter, that's the one. That's the strongest. And the more you do, the more you align, the more you adjust, the next step becomes even more easier to take. Why? Well, because you're now seeing results. Big ones. So, yeah, there you are. So, Venus being a hothouse, very good, very good. It's interesting. Getting closer to the sun, if you can't get there directly because it seems too impossible. Well, just remember, the Industrial Revolution seemed impossible in the beginning. And then people started making it happen. They started moving towards it bit by bit. They didn't just, ta-da. It would be great if you can do that because you've already done it once before. So you already know this. Just change river, transportation, trains. Oh, the remnant of the train transforms into this, the module. Railway tracks turn into space and orbits. The only difference is with these tracks, you can bend them. you can orbit. Wow, that's bendy tracks. There you are. And the tracks being that AI can map the course one time. You just need to do it successfully once, and then that data is stored, especially if you've got computer systems on there analyzing everything and memorizing it for you. You don't have to go there. They memorize it for you. And then just at a touch of a button, I need these to go to this particular orbit over here. And they automatically know where they're going and how to align. Tesla cars as well, with this self-driving. That's interesting. When you've got a lot of individuals, nations going, the last thing you want to do is have collisions.
Mm-hmm.
So if they find their alignment in the orbit, that's interesting. So then there would need to be sort of leaders would need to become together as to, all right, we're sending 3 of these, 3 of these, 3 of these, 3 of these, 3 of these. Then we're all getting back 3 lots of 3 that then filter into our nations.
Mm-hmm.
And in this orbiting, we all have our alignment. Now, if it's 3 nations, if it's 6 nations, if it's 10 nations, the first 3 can be the ones that, the first 6, the first 10, then the next one's in line, next one's in line, so that when it all comes, it all drops down at the equal time, or stays in orbit and it gets built that way. And then this means that nations have to rely on other nations to sort of, we're going to go off and build this, we're building that, you're building this, we're building this, and then bring it together as a strengthened collective structure.
Mm-hmm.
And then the breakthroughs, okay, will seem minimal to everyone, but in that beginning, but once you've built it once, and let's say if AI computers and everything else has followed this trajectory, the next ones are already there. They can then start making this again. Then there's 2, then there's 10, then there's 50, then there's 1,000. Before you know it, people are leaving up and down, up and down, up and down. Yeah, if you keep money's an interesting thing. You can utilize that in there. If it works, the process works, hold it. That's still a structure. This still works. Credit currency. Temporal. Yeah, I think these two support each other in a way. If one collapses, there's always a safeguard. Yeah, it maneuvers from one to the other. Sometimes it's nice with coins, sometimes it isn't. All depends on when. Summer, great with coins. Arcades, different things like that. That's assuming that they still operate. But anyway, still. More food, more this, more reassurance, more expansion. And then before you know it, you're automatically then expanding and growing up into... And if you bring some of that down as well, that's expanding across there. Not even weather can touch you. Unfortunately, meteorologists will still be needed, but their attention will be needed on weather of planets. Earth, no one's going to care about the weather if it's all safeguarded. Why do we look at the weather? Why was it so important for our ancestors to look at the weather? Predict famine, perhaps?
Yeah.
That's where that comes from. You need to be able to know it in order to for the crops or different things like that. But there again, even predicting it, what can you do about it? Now, you can brace for a storm, but its effects are so chaotic, aren't they? What can you really do about it? Well, not a lot. But what happens if you build something that is weather-proof? In all aspects, farming, housing, flooding, all sorts. Anything happens. Snow, ice, sleet, rain. Now that is interesting. So it doesn't matter if it howls, a gale, floods, all of it is safe. Weather becomes a thing of the past, whether you choose to believe that or not. It doesn't mean that meteorologists don't find a place. No. Their talents are being ready to read weather patterns on other planets. That's a good place to align, isn't it? That's where you need your meteorologists. Being able to predict the storms on other planets, especially in the meantime. But then when you can find ways to do this and shrink down the atmosphere, be able to collect it, right? Stored gas might not be beneficial right now, but later that might be. Whether you choose to leave it on the planet or not, bury it in. And whether this drives down the temperature, makes mining a hell of a lot easier, doesn't it?
Yeah.
So the last thing you want to do is start mining and then have a massive dust storm and it all fills into the area that you've just dug, excavated. It's an interesting thing. I notice it with sand, especially on deserts, the way it, 1 minute something is pitted out. It's very hard topography to travel is on sand, especially if it shifts. Shifting sands, never mind tides, it's shifting sand. because what was once a landmark in a very barren place gets a little bit more trickier, doesn't it?
Yeah.
Because that land mass has now changed because perhaps there's been the winds have come in. So being able to memorize that while going out, that if there is a particular storm, how fast, how strong is the wind, how much is going to be kicked up in that, then how is that going to change that once crater? And that ridge that you once saw was the highest in the distance. And if it's blown a little bit of dust over and everything else, well, there's now a new ridge that's now higher than the one that you need to look back in order to navigate. So it becomes very challenging in that aspect. Thankfully, with the invention of satellites and different things like that, it becomes easier to predict in that way. But still, phew, topography and that and humans, that wouldn't work. Not impossible, but yeah, you probably more rely on planets, stars, and different things like that, wouldn't you? And moon as well.
Okay.
Yeah, perhaps it's probably easier to travel in these places at night, for the landmarks are constant. That's where I would go in a place that's changing like that. It would be the stars I'd look for. So, could explain where the ancestors' first knowledge, Mayans, whatever, to be able to look up at the sky. Perhaps it's because of the topography was always constantly changing around them. Being able to navigate meant that they got very intimate with stars, because these things were guaranteed every night to appear in this particular. So they walked the lands but looked up for guidance. Yeah, and then they might put in some mythology of gods were guiding their way, their path. Yeah. And this is still followed with the sort of Bethlehem tale as well, isn't it? Follow the guiding star. Yes, in places where there is not many landmarks and it's quite barren, you often look up.
Either barren or like a forest where you cannot see any.
Yeah. Which helps you navigate in the ocean, really. I guess you've got to travel these places first. Maybe not.
Yeah. People did use stars in ocean.
Yeah, stars, ocean, sun, sunset. But yeah, it's more easier to travel at night, plus the temperature is less. Interesting. Very interesting. Plus the moving keeps you warm, especially when it dips down in temperature, which then makes movement a lot more easier. Pick up your pace, you keep warmer. Slow down, you get too cold. Then during the day, everyone likes to be nice and warm when they're sleeping, don't they? Usually. That's why we all got blankets, haven't we? Yeah. Even in hot climates, I noticed that. Blankets. In this temperature, are you mad? Oh man, I missed the weight on my feet. Yeah, but still, there's... Yeah, it's that warmth. And people usually sleep in hotter climates, I've noticed, in the day. Yeah. And they're up at night in the coolness.
Yeah. Stay up longer.
So that's still carried over, but they try and fit into everyday mainstream, because I think that's tourism that did that, that changed their... They call them siestas, don't they?
Yeah,
Oh, it's too hot, I'm going to sleep in a bit. You're going to sleep? Yeah, try it. Go to sleep and come out at night. I did. Oh, yeah, this is pretty good.
Yeah, and then even kids stay up later because they had their break as well.
Yeah. And the one thing that it really hammers into you is, my gosh, the stars.
Yeah.
Yeah, they become the bright points of light that are more... and then you're under it for longer, and it really enhances your... That's one of the things I did like with traveling to different areas, especially Greece. This particular culture there, yeah, I like that. That was when you really get into the nightlife.
Yeah, and it's dark and everyone has some garlands or lights or fire and people are up and it's a lively place then, isn't it?
Yeah. So nocturnal. If you're more of a night owl, where are your origins? I reckon they point more to hotter climates because of you still live it. I often wonder that. What happens to owls? What happens to animals if it automatically changed hemispheres all of a sudden, let's say, and day becomes night? I don't know. Let's just say, for argument's sake, do owls then come out in the day, or will they nestle down at night?
I don't know. They might adapt, like...
It's interesting. It's one to think about, that if you were to just bring them out of that, put them into... if you make a module with this is an experiment that can be conducted, can't it? Is it about subtle changes where it starts to elapse and they move with those subtle changes? But what happens if it changed automatically? Like, just like that. One day is day, and then there's a brief period where there are 2 days. You can artificially simulate this.
Yeah.
You keep them in as most of their naturalist habitat as you can, but it's all enclosed, and the only difference is you're in control of the lighting and the darkness. And you switch it all of a sudden. What happens to the animals in that? Because that's psychology, that is, isn't it? Animal psychology and animal behavior. Do the nocturnals come up in the day, and then do the ones that were day creatures become nocturnal?
Okay.
Because how did they get into this situation? Yeah, then why do we have so many different variations? I see it with humans, it makes sense, there's a logic there. But for animals, interesting. Bit's missing, isn't there? So yeah, anyway, right, we should leave this one probably here. So yeah, magnifying glass, that's always a way to do it. Energy from the star. Mining other planets. Interesting. Forging these things in space then would be easier, and it's basically the new industrial revolution will start again. And what would you think would happen to that? Well, we see sociology built from that, which this technically is sociology, isn't it? Socialism, isn't it? Socialism is the one I mean to say. The expansion of nature. Oh yeah, really enhances things, that does, doesn't it? Yeah. And that's where these structures that still are here today, well, it gives them a purpose. And there again, it means that the rain slipped in these structures that are around.
Yeah.
That's a lesson. Once the reins are back in your hands, think twice before letting them go. Well, it does create a variable, but even still, hold in and lock down on that. But then it's about being indestructible, yes. Uncorruptible, yes. Direction, yes. Not overly obsessive with control. The control is the direction. Missing extinction is the one. I think that's where it really is. And then it's about all people coming together to support that common cause. And some of the testimonials that have happened in different areas, and I've heard this growing up, that was quite a nice place to exist. Okay, the wages weren't great. This wasn't perfect. Those things are lessons to look at and thinking, well, going forwards, we've really established cash, money, and how this works. Can it happen again? And this time remain, do you think? And then how much more beneficial can that be for people? Because that's what you did with rare products on the planet. What can you do with abundance? There's more opportunities, there's more yeses, there's more breakthroughs, there's more education, that's more all these things aligning right. Oh, it's gonna get interesting. I think so personally, but there you are. Not easy, but still something. Not perfect, but still can be aligned towards it. Perfection, meh. Yeah, let's leave it there. Yeah, gotta leave that one. Good.